Hi everyone, this is Renita, and along with my teammates Indu and Subhashri, we have created a real-time collaborative code editor with health monitoring dashboard. Our goal is to build a scalable, real-time collaborative coding platform where multiple users can write, edit, and review code simultaneously. We have implemented this real-time synchronization of code edits using WebSockets and Redis. Our platform is deployed on Kubernetes for scalability, allowing it to handle high user loads effectively. It also supports multiple room functionality, enabling independent collaborative sessions. We have also ensured persistent session management with robust data storage and built a comprehensive monitoring system using Prometheus to track key metrics like active users, API latency, and WebSocket connections. Talking about the hardware and software used, our front-end uses React.js to provide a seamless user interface with CodeMirror as the primary code editor. The reason for using CodeMirror was its features like syntax highlighting and effective editing tools. The backend is powered by Node.js with Express.js to manage RESTful API endpoints for room creation and session handlings. For real-time synchronizations, we rely on Socket.io to maintain WebSocket connections and Redis to store live session data. Redis pub sub efficiently broadcasts code changes to specific rooms. And we have containerized the application using Kubernetes to support scalable deployments and automated scaling based on user tools. For monitoring, we have used Prometheus to collect and visualize performance metrics like latency, memory usage, and active users in real time, ensuring system reliability and responsiveness.
So moving on with the architecture diagram and component interaction, this is our architecture diagram, and we can see three major components here: the front end, the back end, and session data storage, which is Redis. So the users first interact with the front end, which is built with React and CodeMirror. And from the front end, we basically extract two information from the user, which is the username and the room ID. Based on what the user inputs, the API gateway in the backend will trigger the respective microservice. For example, if the user enters their username, user services will get triggered to save the user data. And when the user inputs the room ID, room services will get triggered to create a new room or to join a user to an existing room. And when they start editing the code, code services will get triggered to help with synchronized updation of code, which we have built with socket programming. And all of these microservices are built with Express.js on top of Node.js. We also use Redis to manage all of the user's session data. We have containerized all of these services using Docker, and we've also deployed it on Kubernetes. As an additional step, we also use Prometheus to scrape all of the metrics from the backend services, like the number of users logged in, the number of rooms created, and the number of API calls made. And we monitor these metrics with the help of Grafana. And we've also created an alerting mechanism with Slack, where we get an alert on Slack whenever a pod fails or when our system runs out of memory. Now we can move on to the demo.
Okay, so for the demo, I have pulled up two instances of my app on my browser here. And here, basically, we can just enter the username and the room ID, and we can join into a room. And we can see here that the number of people in this room are currently one. And I am just going to add another user to the same room. And here we can see that now the number of people are two. So now, whatever code we make in one instance is going to be reflected on all of the users' instances. So this is our basic app. So moving on.
Yeah, here is our Grafana dashboard. So we are using it to monitor our application. And here are some of the visuals that we pulled up. So we are using Prometheus to connect to Grafana and to our app. So you can see some of the status like socket connection. So those data are from the previous testings that we did. And you can see that you can take the time settings to be last 1 hour or 15 minutes or whatever the time settings that you want. So the first one is Redis status, and that tells us about the Redis database status. And the next one is socket connections. The data comes from the socket.io, so how many socket connections have been made in the given time frame. And the next visual is API requests. So it's basically for developers to test if the API requests are running fine or not. And then as a part of the alerting and monitoring system, we also have Slack alerting. So the last dashboard, the last visual is for the Slack alert triggers, and how many triggers have been made in the last hour and stuff can be monitored with this Grafana dashboard. We also have some dashboards to look at the memory usage of our containerization app. So this is how the memory usage is for our containers currently in our system. So you can see the memory usage is at 68.6%, and it's pretty useful to see which of the containers is taking your most of the disk space and the networking aspects as well. So now let's see a quick overview of what it looks at the Prometheus. So we are running service monitor and service discovery on all of the containers that we have deployed on our local system. So you can see some of the containers that we developed, our API gateway, code service, front end, and at the last you can see other containers such as room service, socket service, and user service. So Prometheus collects all of the metrics, and the metrics are coming from the app itself. So it's pretty useful to track how well the containers are performing. And we also have developed an alerting system, which is on Slack. Yeah, so these are some of the triggers that has been running for the past couple of days. So you can see some of the triggers such as resolve triggers and firing triggers. So firings are triggered whenever the targets are down, the metric system is down, and we also get an alert when it has resolved. Basically, the container gets pulled up again. So yeah, so this is our real-time code editor with a monitoring feature along with alerting features. So, yeah.
Now let's see the load handling capacity of our system and potential bottlenecks. The system can handle up to 1,000 active users in this local deployment. Beyond this limit, the time required to broadcast events to all connected clients can increase. This leads to higher latencies in reflecting real-time updates across all users. We also notice that the socket I/O does not natively provide rate limiting mechanisms to server overload. That means developers must implement custom solutions to prevent flooding of the system. Next one is if each user sends frequent updates, that's typing rapidly in the code editor, the system could handle 50 to 100 messages per second comfortably. Beyond this point, messages may queue, causing noticeable delays. Currently, our application is running locally, which limits scaling due to computing resources. We can tackle this by deploying it on Google Kubernetes Engine and enabling auto-scaling of resources with the maximum number of replicas. Now let's take a look at the debug and testing options of our system. To ensure the reliability of our system, we implemented comprehensive logging on both the front end and back end. This allows us to capture errors and tracking performances in real time, and also providing us with some crucial insights about the system. We also use the Prometheus monitoring to monitor all of our microservices, which includes Redis as well, which helped us identify some of the bottlenecks in the system. Finally, we did our manual testing to validate real-time synchronization and scalability, making sure that the platform performs seamlessly across all the users.